Hi, this is Rakesh Gupta, and this is my take on the question 2 of intermediate assessment.
Okay, so I would like to start by talking about what exact ODEs are. So if we have a function which is in terms of x and y, let's call it u of x and y, and this has continuous partial derivatives. So the total differential, or you can say the differential of u of x and y is given by now for this to be an exact ODE, there are two conditions. First, I'm going to write down the first condition and then arrive on the second condition using the first one. So when u of x comma y, when this is a constant, so therefore the derivative of a constant will be 0, and this equation will then become, so we can represent these two terms. We can represent this as m of x comma y and this as n of x comma y. So now we write the general equation for an exact ODE. So this is the general equation for an exact ODE. Also, when we partially differentiate m with respect to y and n with respect to x, so we will get the following. So m with respect to y will be, as we know that m of xy is given as partial differentiation of u with respect to x. So that will be this, and similarly so now when we, like, by the assumption of continuity, we get, so this is our condition for which when u of x comma y is constant, then this equation represents an exact ODE. Now we'll come to our question where our exact ODE is given by this equation. So when we rearrange the terms, we'll get something as follows. Now when we compare this equation to the exact ODE equation, we'll get, so I got this by comparing the two equations. Now we have to apply this condition so as we get a relation between the constants present in the question. So the partial differentiation of m with respect to y will give us as ax does not have a y term in it, it will be considered as a constant, and by, the differentiation of by with respect to y is b. Similarly, we differentiate n with respect to x, so we get, similarly ly will be considered as a constant, and the differentiation of kx with respect to x is k. So according to this condition, we both of these are equal. So when b is equal to k, that is when this equation, which is given in the question, represents an exact ODE. So only the constant should only satisfy this condition. So for any value of a and for any value of a and l, uh, it, any value of a and l, it does not matter. Only b is equal to k should be satisfied. So now, when we solve further, we can write the function u as integral of m dx plus some function of y, which we're going to get. Or we can also write this as integral of n dy, this is n, sorry, plus some function of x. So we are going to solve by using this. So when we substitute m, we have m as ax plus by. So integral of ax plus by dx plus some constant k of y. Sorry, not a constant, some expression k of y in terms of y. Now integrating. Now we differentiate this entire equation with respect to y. So we'll get, now this will be treated as a constant because there's no y term, so it will be 0 plus bx plus the differentiation of k of y. So now we know that the differentiation of u with respect to y, sorry, 1 minute, let me find that. Yeah, the differentiation of u with respect to y, the differentiation of u with respect to y is nothing but n of x and y, and over here we have n of x and y as this. So we putting these values into our answer over here, which is kx plus ly. So kx plus ly is equal to bx plus, I'm just going to write this as d of k by dy. Now when we rearrange, we'll get dk by dy as, now if you remember, we got a condition which said b is equal to k. So when b is equal to k, this term and this term are going to cancel out. So solving further, now we integrate on both the sides. We get k is equal to ly square by 2 plus a constant of integration c. Now we know our function k. Now we put this. Now we put this into the equation we have over here, which will then get us, right, ax square by 2 bxy plus our function k of y Now, if you remember, if you recall, so what happens is our function u is a constant for the condition, one of the conditions for it to be an exact ODE, u of x or y should be a constant. So, as u is also a constant, which we can call c, and we have another constant over here, we can just write this as, we can just write the equation as, so this constant and this constant when rearranged will again give a constant. So I'm just going to write it as a single term and equal to 0. So this is our answer. That's all. Thank you.